Hello and welcome. So the topic that we are going to talk about is how switch switches. So the agenda, as you can see, first of all, we are going to talk about one of the old technologies that we've been using in the back old days. It's topology. Okay. Then I will talk about the switch and the backplane of the switch. Then how switch usually does a switching. Then, from the perspective of cybersecurity, network security, and some common interview questions which you have to submit as an assignment. So let's head over the next slide. So which is talking about the old technology that we used to use was bus technology. So if you just can take a look of this diagram, as you can see, we have one this single cable. This is used to call a backbone cable or a bus. Basically, this is a bus topology. As you can see on the same single cable, we have multiple computers are attached. And let's suppose if it is mentioned then if machine 2 wants to send a message to machine 4, but it listen to the cable. So let's suppose if machine 2 wants to communicate with 4, first of all this machine will send some kind of mechanism on this cable to know whether all machines are in a silent mode or they are idle. So if this cable is idle, then only 2 is going to send a message to the 4 and vice versa. So this is how the bus topology or technology works in old days. So is to of course if 2 sends a packet and the 4 packets, as you can see over here, let's suppose PC1 and PC2 sends a packet at the same time. Then this packet you can see is gonna collide over here. So to avoid this thing, the term is called CSMA/CD, which stand for carrier sense with multiple access slash collision detection. Okay, so just we will do one by one. Carrier sense. First of all, these computer is going to sense the carrier. Okay, so this is the carrier they are going to sense. Multiple access means all computers have multiple access, so they can access anytime. Okay, if the collision happens, then they are going to mitigate using a collision detection, or they will find a collision detection. So this CSMA/CD is the mechanism they were using in the old technology. Okay, so let's suppose if they send this packet at the same time and then it collided. So for that, they are gonna use what called back of timer. So if the channel is not clear, the node waits for a randomly chosen period of time. So they will revert all communication back and then they gonna wait for some time. That thing is called back of timer. It could be like some kind of milliseconds, 1 minute, something like that. Okay, so they are gonna wait for that time and then they will transmit the data again. Okay, so the what is jam signal? 32-bit odd binary pattern sent by the station to inform the other station of the collision and that they must not transmit. Okay, so this is the back timer for the time they will wait, and then they will also send a jam signal. So basically they are informing other stations telling that we are going to go into the back of timer. So if anyone want to send or transmit the data, they can send. Meanwhile they will be hold on. Okay, so what happens is that machine 2 and 5 decides to transmit at the same time. So this is happens what is called the collision. Okay, and then they will send a jam signal to aware all other devices. Okay, okay, we know that we had a problem in the bus topology. So the engineers came up with the idea called the switches, and we have already talked about the switches in detail. So basically what happens behind the scene in the switch, you know, In the bus topology, we have same this cable where these all computers are attached. So if this sender is sending a packet, maybe this one also sending a packet, and there could be a collision. So it means there is one main collision domain, and also there is one broadcast domain as well. Means if this computer will send the packet or the frame, it is going to receive this computer, it is going to be received by this computer, it is going to be received by this computer. In the switch, so first thing first, how switch does switches? So switches do not use the concept of CSMA/CD because um, rarely their collision happens. Okay, so there is no basic collision happens, so that is why they do not use the concept of CSMA/CD. Second thing, they use a table inside their memory called CAM table, which is uh, stand for content addressable memory. Okay, so this is just kind of a table where it will keep the information about these all resources connected to its this device. Okay, and we will talk about this in a later slides. So switches have one broadcast domain but multiple collision domains. What does it mean? It means when this computer, let's say this is PC1, wants to communicate with PC number 5, when it will send this transmission or the frame, this frame is going to receive by this computer, by this computer, by this computer, by this computer, this computer, this, and the printer as well. So that is why there is one single broadcast domain. On other hand, in bus topology, we have collision domains. Sorry, one collision domain. But in case of switch, we have multiple collision domains. Okay, because again, if I draw the bus topology, this is the bus topology. Okay, this is going to be your uh, logical topology. But if I correlate with the switch, how switch basically happens behind the scene. So there is some method like you can make, just a minute, make it like a ring. Okay, and this switch is connected with this one, this is connected with this one, this is connected with this one, this is connected with this one. Sorry, I will come back. Sorry, I will repeat. There is a ring. Let's suppose we have multiple rings. This port is connected with this one is connected with this one, this one is connected with this one, this one is connected with this one is connected with this one, and then further on and on. Okay, so as you can see now, before we had one single bus, okay, where packet is being sent or received. But in case of this one, if this user wants to send, for example, information, it is going to be inside here in this ring topology. So it means if this computer wants to send, it has separate topology or a backplane. Basically, this thing is called the backplane. Okay, and we have multiple type of backplane, but I'm not going to go in detail. So this is just, we will stick with this ring kind of topology. Okay, so as you can see, there is no any kind of collision happenings. So it means it is going to have multiple collision domains. So we have one domain, second domain, third, fourth. So every port of the switch is going to have separate collision domain. Okay, domain. So it means this is not going to collide with this one is not going to collide with this one, and so on and on. Then switches could be manageable or unmanageable, and we have already talked about it. For example, if I'll talk about the hub, hub is a dumb device. Hub is a dumb device. So if you will send some packet from the source and we have multiple destination, it is just spit it out everywhere without knowing where the destination is. Okay. But in case of the switch initially start as a hub because it doesn't know about these devices. But now we have some mechanism called gratuitous ARP. Gratuitous ARP. With the help of that, it is going to populate its CAM table, which I was talking about here. But initially, switch starts with a hub. It is going to send this broadcast information everywhere. And then after that, it is going to populate its CAM table, which I'm going to show you in the next slide. Okay, so once the CAM table is flooded with the information regarding the MAC address table and the port number, then this communication is going to be a unicast, which in the next slide. So let's go to the next slide. So as you can see, this is called CAM table. And on the port number 1, this computer is connected whose MAC address is quad A. Similarly, on port number 2, this computer number B is connected whose MAC address is B. Okay, so basically three kind of things the switch does when it is going to send the frame. So what happens in the first one is called flooding, second one is forwarding, and third one is filtering. So what are these things? First thing first, the flooding. If the destination MAC address is not in the CAM table, okay, if the CAM table is empty or does not have information about the destination MAC address, then the switch is going to flood this traffic to all ports to know about that destination MAC address. Okay, and usually it is done using broadcast, which is all F. Then we have forwarding. Forwarding is the case when this CAM table not only having the source MAC address, also the destination MAC address in its CAM table. So of course, if the source is coming and hitting to the destination, switch CAM table, switch will go into this CAM table and will find out, okay, the destination is connected on the port number 3. So this information we sent, it is called forwarding, and this is unicast. It is one-to-one because switch is already aware about the source and destination MAC. But this flooding is broadcast. So as you can see over here. And the third one is called filtering. The filtering the case, for example, we have this switch, we have the destination over here. Then in between, let's suppose we have some kind of hub device. Hub is connected. And then this hub is connected with multiple computers. Okay, so they are all connected on fast Ethernet 0/0 on the same port. So if they are connected on the same port, these all devices, okay, then the for example, if it wants to send a packet to or send a frame to this computer, then this information is not going to flood everywhere, but this switch is intelligent enough. It knows that my all these information are connected on the same port, so that is why I need to filter it out, the traffic. Okay, so it will remain in the same domain. So in the next slide, as you can see, we have some communications going on. So before I describe each and everything, first I just want to show you this is my PC1 whose MAC address is AAA, and let's suppose the IP address is 192.168.1.1, and it's want to send the information to PC3. Okay, so PC3 has MAC address of CCC with the IP address of 192.168.1.2. So if we can show you what happens. So if I will come back again, so let the animation finish first. Okay, so PC1 sends the frame to PC3. Okay, so it is sending the information. So basically it is sending any kind of packet like ping packet, okay, ICMP packet. So this switch is gonna receive this one, and now what the switch one is going to do, it receive the frame and check the source MAC address against this against the MAC table. So it is going to check whether this MAC address table AAA exists in its CAM table or no. As you can see, this is empty. So what is going to happen? No match found. And then it is going to add this one because switch is always going to populate the CAM address table using its source MAC address. Okay, then you can see this was source. Now it has clear understanding on fast Ethernet 0/1. Can show you from fast Ethernet 0/1 um, AAA MAC address table it has populated. Okay, in its CAM table. Okay, so now as you can see, the destination is unknown. So that is why it just for broadcast this all traffic to everywhere. But now you can see over here, PC2 looked into the destination IP address, okay, and it said that okay, no, this frame is not destined for me because it is destined for 192.168.1.2. Similarly, PC4 checked the frame. It said that yeah, this frame is also not for me either. Then it went for 192.168.1.2, and this when this PC3 received this frame, it said, yeah, this is for me. So I have to reply back with my own MAC address table. So as you can see now, PC3 replies back with having CCC in it as a source MAC address, and the destination MAC is going to be there. But before it hits this PC, now this switch is going to check whether do I have this MAC address table in my CAM table, and it's set. If no, then it is going to fill it out, and then source MAC address, since it's already there. Okay, so that is why it's forwarded the packet to the PC1. But next time if PC1 sends to PC3, and if the CAM table is having the information about uh, these AAA and CCC in its MAC address table, it is going to send only to PC3. Okay, so this is called unicast, but initially they start with a broadcast. So I hope you get the idea. So let's head up to the next slide, which is talking about from the perspective of cybersecurity or network security. So since we are talking about MAC addresses, it means on OSA layer, we are talking about the data link layer where we have MAC addresses and LLCs basically. Okay. One of the applications that attackers use to attack at this layer is called DSNF tool, or this is also known as MAGOF tool. Okay. So what kind of attackers attack using this application is called MAG flooding. As you can suggest from the name, it is going to flood the victim with so many random MAC addresses. As you can see over here, it is just going to give the syntax MACoff, then it is going to use Ethernet 0 as interface, and then it is going to transmit the destination of 192.168.0.1, and it is going to flood many MAC address um, you know addresses. So as you can see, we have tons and tons of MAC addresses which is heading to 192.168.0.1. Okay, so you can see ton and ton of. So what will happen? I just can a little bit explain here. We have a switch here. This is a source, but it is not source but the attacker, and we have the destination over here with the IP address 192.168.0.1. Okay, so but in such case, basically what it is doing, it is not attacking to switch, but it is going to attack this my PC. So what will happen, because the my PC also have some kind of ARP table, which we are going to cover in the next slide. Okay, so what will happen when this source or the victim is going to broadcast or flood so many MAC addresses destined to 192.168.0.1. So what will happen? What will happen? This destination machine has ARP cache, where basically it is going to save, you know, these MAC addresses. And let's say the limit of these MAC addresses are 15,000. Means maximum MAC addresses the 192.168.0.1 can hold are 15,000. So let's suppose this go beyond 15,000. So what this computer is going to do? It is going to suffocate, end up having choking, or means you cannot access any services of this destination machine. Okay, so this machine cannot uh, access any kind of services. Similarly, if we attack on a switch, we, as we already know, has a CAM table. And let's say CAM table can possess 30,000 MAC addresses. Attacker is going to attack with, let's say, 50,000 MAC addresses. So what is gonna happen? Eventually, this CAM table is going to flood with 30,000 MAC addresses. And then if here we have some legitimate source who want to send the packet to some destination, but my switch is can say overflowed with these MAC addresses. So that is why it will not gonna entertain, and it is going to flood this traffic everywhere. Okay, although the destination is going to receive and it is going to reply back, but you can see every time source is sending the information, it is going to flood out and replies coming back from all users. So if the attacker is there, he or she can sniff the information and can exploit whatever he or she wanted to. So the solution of MAC flooding is MAC filtering or port security. So I am just going to give you example of MAC filtering. So what happens in a production environment? Let's suppose we have this one switch, and let's suppose in case of our scenario, we have only three switches. Sorry, three laptops. So in switch, I will tell the switch, let's suppose they have triple A MAC address, MAC address information. It is have BBB as a MAC address, and this one is having CCC. So I'm gonna go in the switch and I will tell the switch that if the request is coming from port 1, it will be coming from AAA only. If it is coming from port 2, it is coming from BBB, and CCC from the port number 3. Okay, and we are hard coded these MAC address inside this CAM table. Okay, if let's suppose this MAC address table has been changed and it has become like LLL. So when this request will come, it will be discarded. Okay, so we have hard coded our MAC address table, by the way. So with the help of that, we are going to mitigate these MAC flooding issues. So some common interview question and answer as an assignment. So first thing first, what is CAM table? Switch populate table using source MAC or destination MAC. What is the broadcast address from the perspective of switches? What is ARP and how switch switches? So you have to give a brief on how switch basically does a switching. Okay, so with that, our switching video comes to end, and I'm going to see you